Dear students, welcome to my video tutorial, Brush Up Zoology class. And as requested by some of my students to give a video lecture on aortic arches, so here I am taking a class on comparative account of aortic arches or arterial system, arterial system in vertebrates, where we would be talking about aortic arches in particular in the vertebrates. So arterial system, particularly of the head region, it varies in adult vertebrates, but a study of its development, it shows that it has the same basic plan, but there is diversity of arrangement which is due to mainly two factors. There are two factors because of which this arrangement it varies. Number one is the change in respiratory organs. Change in respiratory organs. That is, if we talk about the fish that has the gills, and two, if we talk about tetrapods, they have the lungs. So there is switching on of respiratory mode from bronchial mode to, let's say, the pulmonary mode. Second is the second factor because of which this diverse arrangement of aortic arches occurs, that is change of circulatory system, evolution of heart from two chambered, in case of, let's say, in case of fish, to four chambered heart. So these two arrangements, they make a difference in the arrangement of, hence that affects the arrangement of aortic arches also. So there is a basic plan for aortic arches, or the fundamental plan of aortic arches. What is that fundamental plan? Basically, the number of aortic arches, it is considered to be 6 pairs. Whatever be the number of aortic arches in adult, the embryos of vertebrates, they pass through this stage, having 6 pairs of aortic arches. However, some of the lower vertebrates, they can be exceptions. Exceptions are there because they have more number of aortic arches than a typical number of aortic arches. First indication of aortic arch in the embryo is the formation of a vessel. This vessel is the very first indication of aortic arches, which is called as the ventral aorta. And this ventral aorta, that is formed right in front of the heart. This ventral aorta, it would join the conus arteriosus at the back, and in front it would divide into a pair of vessels. So there is a division. It has divided into two in front, and which then, out of which from the latter arises the first pair of aortic arches, from which extend upwards behind the first pair of pharyngeal pouch. So from here arise these first pair of aortic arches, which would run behind the first pair of pharyngeal pouch, and then after joining it, it would run backward. And the vessel that runs backward is called as lateral dorsal aorta, and it would be on both the sides. So these are the lateral dorsal aortae. Plural is aortae. And these lateral aortae, these behind the pharynx, two dorsal aortae, they converge and they meet in the center like this. They meet in the center, and where they, along mid dorsal line, they run as, it runs as rather, median dorsal aorta. This median dorsal aorta, it would continue backward, and on the way it would give off a number of pair of arteries at the posterior end, and at the end it would end as caudal artery. Right? 5 more pairs of aortic arches, they arise from the ventral aorta, as we've seen. First pair is this one, and then there is, let's say, the second pair that also arises from the ventral aorta, and it would run behind the branchial pouch, pharyngeal pouch, and then it would join the lateral dorsal aorta. Similar phase. This is the third one, and this is the fourth one, fifth one, and hence the sixth one. And they are joining like this, the lateral aorta. So this is the basic plan, and the similar thing is seen on the other end also. The sixth aortic arch. So these are from 1 to 6 pair of aortic arches, which is the basic plan. And they would, when the gills, they develop in the pharyngeal gill clefts, the aortic arches, they break up into capillaries within the gills, and with the result, each aortic arch, which it basically shows 2 parts, that is afferent branchial artery and efferent branchial artery. Why so? Why these names are given that fashion? That respectively, these are named, the aortic arches are named after the visceral arches. That then you have to visit the visceral chapter on visceral arches. Both lie in the, because the visceral arches as well as the aortic arches, they are lying in interbranchial septa. Accordingly, the first aortic arch, this one, is called as mandibular arch, aortic arch, after the name of mandibular visceral arch, and the second one is called as hyoid arch, whereas the rest of the 4, these are called as the branchial arches, which would be named as first to fourth branchial arches. So that is the basic plan. Each aortic arch it lies in front of the corresponding visceral cleft. Anterior continuation of the lateral dorsal aortae, these ones, the lateral dorsal aortae, these continuations, these are called as the radices. Radix is the singular, and these would carry blood to the head region. This part would carry blood to head region. So this is the basic plan of aortic arches. After this, we'll come to the next part, that is the changes in the aortic arch. So first of all, we'll talk about, let's say, we'll talk about changes in, or the evolution in, aortic arches. So first of all, we'll have a look at the aortic arches. They go on changing, they correspond to the changes of the respiratory organs as well as heart, as I mentioned earlier also. So first one is, we'll have a look at branchiostoma. What happens in branchiostoma? So branchiostoma, here the ventral aorta of branchiostoma, it is called as heart. It is known as heart because it shows some kind of pulse. It is pulsatile. It shows rhythmic contraction. So it gives off, if we look at the branchiostoma, anterior part of the branchiostoma, suppose this is the I'm drawing the outline of branchiostoma, and this is the gut region of the branchiostoma, right? So it has a ventral aorta. Let's say this is the ventral aorta. So ventral aorta, from ventral aorta, it gives off on both the sides. Let's say we are just seeing the front end. On the front side, it gives off the primary afferent, that is afferent branchial. It gives off afferent branchial arteries alternatively, and these extend upward, and these are passing through the primary gilbars, and on the anterior end, on the upper end, sorry, on the dorsal end, it swells to form a bulbulus, or let's say bulbule, and which assists in circulation of blood. So it runs through the afferent artery. It is running through the primary gilbar. Similarly, through the secondary gilbar also are passing through these gilbars are the another afferent arteries, which are secondary afferent arteries. We can call these as afferent arteries. Simply they are passing through the secondary gilbars. They also have afferent branchial arteries, but they do not get their blood from the ventral aorta. Rather, they are getting blood through these transverse connections which are passing through the synapticula. The afferent branchial artery of both primary and secondary gilbars, they leave the gilbars dorsally and they meet ultimately they open into a paired lateral dorsal aorta. So this is a paired, it runs in pair. So these are the lateral dorsal aorta. On dorsal side, the two are running dorsally, which posteriorly they combine and they run as single vessel, which is called as the median dorsal aorta, right? And finally, median dorsal aorta, it extends backwards and then it supplies different visceral organs at the posterior end. Whereas the lateral dorsal aorta, they extend in anterior portion, in the head region, in the snout region we can say, and that supplies blood to the snout as well as oral hood. It has oral hood here, right? So that these two lateral dorsal aorta, they would supply blood to the oral hood and snout. And branchiostoma, it has numerous number of aortic arches, 180 pairs of aortic arches it has, and these do not break up into capillaries in the gilbars. As I mentioned in the basic plan, they might break up into the capillary network, but as such they do not break up into capillary network in the gilbars, because there is as such no gills are formed in branchiostoma, and hence little oxygenation of blood occurs in the aortic arches. However, aortic arches break up to form certain small plexus which are called as glomi near the excretory organs nephridia. At no other site they would break up. So that was about the the scheme of the aortic arches in case of branchiostoma. That is all for now, and we continue in the next lecture.